Welcome back to JEC Connect 2021, the Startup Booster. Now, here's the thing. If you were with me and with us all this morning from 10 to about 11:30, you would have, I'm sure, enjoyed the many innovative ideas, big ideas that we heard, and the jury members asked the questions, dug a little bit deeper and found out more about these wonderful ideas. So if you've enjoyed that, you're going to enjoy this next hour together with us right now. And if you weren't with us this morning, let me just quickly explain what this is essentially all about. So Startup Booster competition. This is really the startup competition within the composites industry. This is the competition all startups really want to be a part of. So from 2017, when it first launched, we've seen the emergence of more than 500 different big ideas, innovative ideas that have popped up pretty much around the world, and this network is pushing those ideas forward even as we speak. And this edition no less, has an application of more than 200 different ideas. What we did, we basically teams from JEC, Daimler, Airbus and Magna together sat down and chose 20 out of 200, 20 of those best exciting startups. 10 of them we heard this morning, and 10 we're going to hear right now. We're going to hear right now. They have simply 3 minutes, no more, 3 minutes to share their ideas, and then after that, 2 minutes from the jury members to dig a little bit deeper underneath the bonnet to find out really what makes these startups tick. Now, probably at this stage you're thinking, what on earth is the prize? What do they walk away with as winners of this competition? We're looking for 3 winners, 3 equal winners of the competition, and each of them will receive 3,500 euros in a financial prize and a fully equipped booth at JEC World 2022 right here in Paris next year, which naturally gives them lots of exposure and, maybe more importantly, a chance to have the conversations they need with the right people at the right time at JEC World next year to really move forward in the right direction. And again, this is a competition that would not be possible at all without the support, without the loyal, faithful support of our innovation partners, Airbus, Daimler, and for this year as well, Magna, and equally our recruitment partners as well, who really help spread the word in terms of the competition and getting as many as applications as we can, which is literally 200, more than 200 across 30 different countries. Right. I think it's time to introduce or reintroduce the jury members. Those of you that are with us, you'll know who these jury members are. If you weren't with us, let me quickly just remind you exactly who we have. So, first of all, we have the head of manufacturing technologies of Composites at Airbus, Jelle Blumhoff. Jelle, are you with us? Hello. Jelle, nice to see you again. It was a busy morning, and I'm sure it's already overload with great ideas. Well, guess what? You're about to hear another 10 great ideas as well. So welcome back. We also have Thomas Canova, head of Solvay Ventures from Solvay, obviously. Thomas, are you with us?
Yes, I'm with you.
Great. I can hear you. We can't actually see you. Are visually, can we see? Wonderful. You look even better when we see you. Right. Thomas, back again. Looking forward to hearing your comments and questions for our pictures as well. We also have a gentleman that we see year on, year out supporting the Startup Booster, and naturally we see him many times in Paris for JEC World as well. The manager of Future Outsider Materials at Daimler, Karl-Heinz Fuller. Karl-Heinz, are you there? Wonderful.
Hello together.
Wonderful, nice to see you back. And again, looking forward to your comments and what you think of the big ideas as well. We also have a gentleman who's joining us right now for the jury, Global Director of Innovation at Magna Exteriors, Brian Krull. Brian, you with us?
I'm here. Thank you, Peter.
Fantastic. Just a quick question for you, Brian. You weren't with us this morning. You haven't seen the startups. You're about to see 10 new ones right now. If there was something that you are looking for that makes you go, that says to you, yes, this is something I need to follow. I need to be more curious about, what would it be?
You know, really advancing startups is something that we look to do at Magna. Big history of that internally at the company. As I look to the future, it's really cost sustainable approaches to innovation that we can bring to our customers, and ultimately the startups bring to us. So really excited to be a part of the Startup Booster today.
Fantastic. And we also have Managing Director of BASF Venture Capital, Marcus Solobieda. Marcus, you're with us once again.
Yes, hello. Hi.
Hello, right. Okay, relaxed. He's cool. He's in his chair. He's ready to hear these next 10 great ideas. So thank you very much, jury members. And all that really leaves me now to say is it's time to move on to our big ideas. Again, 10 big ideas. We're looking for three from 10 this morning and from the 10 this afternoon. So after this hour together, this evening at some stage, we will know, well, the jury members will know, and here at JEC, the staff, the team here, we will know, but tomorrow afternoon at 2:30, we'll be able to share during the award ceremony who those lucky three, I always say lucky, it's actually well-deserved three winners will actually be. Right, let's move on to our first finalist of this section. So, we move on to the first finalist, which is actually the winner of the Startup Booster JEC Forum Chicago, Continuous Composites, and the CEO of Continuous Composites, Tyler Alvarado. Tyler, are you with us?
Yes, sir, I am, Peter.
Absolutely. I reckon I remember you very well. We met a few years ago when you won the title. You're here. You're finally here. We're not here physically, but you're here through the screen. Are you ready to impress who you have to impress?
Absolutely.
Okay, wonderful. 3 minutes, over to you.
Thank you, Peter. At Continuous Composites, we are introducing the next generation of composites manufacturing. Composites are a superior material from a strength to weight ratio. They have a low CTE and they're non-corrosive. The downside to composite materials, though, is the traditional manufacturing processes. Most of them are very manual and labor intensive. They require expensive tooling and autoclaves and ovens, which ultimately drive up the finished composite part and limit its applications to very high-end applications like aerospace, defense, and high-end premium products. At Continuous Composites, we are introducing the next generation of composites manufacturing. Some of the recent innovations in this space has been automated fiber placement and automated tape laying, which removes the dependency of skilled labor and increases the material consumption, 3D printing of composite tooling, and vacuum-assisted resin transfer molding. But these are all incremental improvements to the traditional techniques of manufacturing composites. Here at Continuous Composites, we have patented and are developing our continuous fiber 3D printing technology, or CF3D for short. This is a fundamental shift in the way you manufacture composites. It leverages composite materials, additive manufacturing, and robotics, and it eliminates the costly constraints of all the traditional processes. This is true continuous fiber 3D printing at very high fiber volume fractions at very low porosity. And this technology offers a very diverse range of resins and fibers to match your materials for the specific application. This technology leverages snap-curing thermoset resins to dynamically steer fibers in all 3 dimensions and is not only limited to structural composites, but can also be used for very high temperature composites like carbon-bonded carbon or ceramic matrix composite parts. At Continuous Composites, the result of this technology is a fully automated process that has a very high material yield. You can manufacture very complex organic geometries at the click of a mouse. The result is a very low-cost composite manufacturing process. Behind this technology is a very extensive patent portfolio, both U.S. and domestic, covering the process, hardware, software, materials, and beyond. Our team is comprised of over 30 professionals ranging from engineering, business, intellectual property that's very well suited for bringing this technology to market. Our business model is to offer one solution, which is comprised of both the motion platform print heads, the toolpath generation software, and a very robust supply chain of materials providing access to this technology. And we're very focused on bringing our production system to market, which is a 6-axis industrial robot arm targeted across the US and Europe over the next 12 months. This technology and industry is growing rapidly as a result of very high performance materials like this being offered, and we are bringing this technology to market. We're working with customers right now on funded projects and strategic early adopters of the technology, and we look forward to hearing from you. Thank you so much for your time, and I look questions.
Oh, wonderful. Right, I just had to stop you there just a few seconds, but you did it. You actually did it in time. So wonderful. Thank you so much. Right. Let's hear from our jury members and hear how they felt about what they've just heard. And I think Thomas has got a first question already for you, Tyler.
Yeah. So thanks a lot, Tyler, for your pitch. So my question is on partnerships. So if we look at the value chain, at the upstream section of your value chain, so how critical is for you to develop strategic partnerships on developing new materials?
It's very important. Our innovation really is a materials innovation. We have partnered with Arkema and their subsidiary Sartomer. We have a joint development agreement where we're developing this diverse library of resins for our process, and they're also an investor in Continuous Composites. We also have a partnership with Saint-Gobain on the development of this for aerospace applications as well as on their fiber division, and we're always looking for additional partners.
Okay, thank you very much.
You're welcome.
Anybody else from the jury? I'm not quite sure what that question was, but it didn't sound. It sounded like a very high voiced. Can we do that again? Maybe Yellow once again ask the question. Yellow, it's okay. If you can hear her, and you probably don't know why we're laughing, but the voice coming through, the sound is very much like a Smurf. I know you don't sound like a Smurf, but it does sound like it, and that's why we're smiling, and we can't hear the question. Maybe once again, try again? Maybe not. Okay, what we'll do, we'll stop there, and okay, right, we'll stop there. Okay, any other questions from somebody else, maybe with a lower voice?
Yeah,
maybe I have a question,
okay.
If it's possible.
Does it work?
Please go ahead.
No, just to understand, are you, in terms of the materials you use, is it a combined system, your hardware and the material, or is it an open system where you say you have the hardware and you are open to a different set of materials?
Yeah, so the fibers that we use are typically off-the-shelf continuous fibers. So, any carbon fiber manufacturer or glass fiber we can leverage. The resin systems are a developed resin system that are specific for our process that work with the continuous fibers that the customer's choosing. We currently have about 12 different resins available, and that library of resins is continuing to grow. We've developed those a lot of times through customer-driven objectives when they're specifying smoke, fire, and toxicity requirements, or the glass transition temperature, for example, of the resin. So the resin systems aren't necessarily just off the shelf, but there is the ability to tailor the resins and the materials for specific applications.
Wonderful. Okay, what we'll do then, we'll stop there with the questions. Tyler, thank you so much. Good luck, and we'll only find out tomorrow during the award ceremony if, you might find out before that, hopefully, but everyone else, hopefully might see you in the final tomorrow. Thank you so much.
Sounds good. Thank you, Peter.
Wonderful.
Appreciate all your guys'.
Bye-bye. Oh, by the way, are you still there? Where? Oh, you've gone. Yele, if you're still there, we'll ask you to reconnect. If you can reconnect, and hopefully we'll get your normal voice back to where it should be.
Better now, because I did reconnect now. Is it better?
That's much better. Is that Yele?
Oh, wonderful. Okay.
Beautiful. You sound beautiful. Wonderful. Okay. Let's move on. We move on now to our next finalist, second finalist of this second section, and we move across we stay in the US, in fact, and we're going to listen to Endeavour Composites, the president of Endeavour Composites, which is Hicham Goshen. Hicham, are you with us? Right, you're with us. Just maybe unmute.
I did.
Wonderful. You did, and we can hear you perfectly. Wonderful. Where are you right now in the US?
Knoxville, Tennessee.
Tennessee. Beautiful.
Yes, right. The background of Oak Ridge National Lab.
Fantastic. Right. Are you ready? I'm sure you are ready. You've got your presentation ready, and we're ready to hear what you have to share. 3 minutes, over to you.
Thank you. Can you see my slide? Okay. So my name is Hicham Goshen. I'm the president of Endeavour Composites. We are a nonwoven fabric manufacturer providing turnkey solution for the composite industry. As you know, the composite market is on the rise, especially carbon fiber is reaching 120,000 tons a year in demand. But what people don't talk about is that the composite, especially carbon fiber manufacturing, is a 70% yield production. So 30% of the production goes to landfill every year, equating $1 billion in value. A lot of people have tried to approach this problem by milling the fiber, which add no financial or mechanical values, compounding them, which add a lot of energy costs to the process and cause fiber length attrition. And several have tried nonwoven because it's appealing to preserving the fiber length retention and low cost of production, but they couldn't pass half an inch or 12 millimeter in fiber length. Our patented process preserve fiber length attrition and intercept those fibers from landfill, create tailored nonwovens with high output, low cost, defect free. And these turnkey preforms can be multifunctional as we can use any sort of fibers with the carbon fiber, adding $15 billion in value. Sorry. The elimination of defect and using long fiber have allowed us to compete in performance by increasing the interlaminar shear by 83% and tensile strength by 52%. Our business model is to place strategic partnership with carbon fiber OEMs and composite recycler to create these turnkey preforms that fits the composite industry existing equipment in a plug-and-play system, tailored properties, and increase functionality and unlock new potentials. The market opportunity size, currently, if we look at the automotive only, they're consuming $100 million worth of carbon fiber, which will turn into $600 million in revenue in the next 3 years. So far, we've raised $1 million in non-dilutive funding, thanks to the several agencies in the US government. And we've partnered in R&D with major players in the industry. A big shout out to our board of directors that's split between deep expertise in technology commercialization, an angel investor, and a VC investor. Last but not least, we have a great engineering team with business background as well that's been a great support. We remain at your disposal for any information, and we're looking forward for future strategic partnership and investment opportunities.
Hicham, wonderful. Thank you so much. Over there in Tennessee. You're in Tennessee. Our jury members are pretty much spread out across Europe, and we're going to hear now exactly how they felt about what you just shared. So I believe right now, Yele has a question for you right now.
Yeah, thank you. I would like to know and to understand how you derive these longer fibers, because the longer, I think, the better. And the second question is, how do you control a defect-free preform?
Yes, sir. So our process changed the wet late performance from everybody's been trying to solve it from a chemistry perspective. We worked more on the mixer side. We created a very unique mixer that controlled the physics aspect of it. And that's what we were able to patent in creating a system that can disperse equally and at a very high speed without subjecting the fibers to very long period of time of currents, which cause roping defects. by shortening the time of mixing and creating a wide distribution. Imagine it as multiple tornadoes hitting each other at once. That's how we were able to spread it much faster.
And how do you control a defect-free preform?
By completely defilamentizing the tow, we spread the tow to the maximum, so there is no log defects, which is fibers that are undispersed, and we prevent the fibers from having the time to tangle with each other because we move the system extremely fast, and that will prevent any rope defect, which is fibers rolling on themselves and tangling together.
Okay, thank you.
Just a little bit more time, 20 seconds, last question perhaps. No, okay, we'll take that as the jury is satisfied and they've heard enough to make their own decisions about what they've just heard. Hicham, thank you so much, and hopefully, well, we don't know, but maybe we'll see you again tomorrow as one of our winners. So thank you so much. Right, before we go on to our next finalist, so already you've heard that we are naturally here in Paris, in the center of Paris, in this beautiful, beautiful studio, virtual studio. You know where we are, but we would love to know where you are. Let us know in the chat exactly where you are. This morning, literally, we had people from 4 corners of the globe: Taiwan, Uruguay, South America, South Africa, Luxembourg, France. We had people from everywhere. Let us know where you are, and maybe if there's a specific startup you're rooting for, let us know. Let us know what you think as well. Right, we move on now to our next finalist of this session, our third finalist, and this is a startup simply called Icomat. They're from the UK, and the CEO is about to join us right now, Evangelos Simpeloudis. I'm sure I said that wrong. Did I say that right or wrong?
Hello, Peter. No, I think it was excellent pronunciation. Thank you very much.
You're welcome. Right, where are you right now in the UK?
Bristol.
Bristol, right.
This is the heart of the composites.
The heart, that's absolutely right. Bristol. 2 great football teams as well, Bristol City and Bristol Rovers. Right, are you ready? Yes, you are. I'm sure you are. 3 minutes is yours.
So, composites stand for lightweighting, but this is no longer enough. There is now more pressure than ever to deliver even lighter composite structures and produce parts at a lower cost and much higher rates. As you all know, composites are only strong in the fiber direction, and to compensate for this, we stack layers at different orientations, giving the same strength in the main directions. But the structure is never loaded the same in all directions, and it would be far more efficient to steer the fibers and reinforce only the critical areas. This gives us parts which are lighter and require less layers, so they are cheaper and faster to produce. Sadly, this is not possible with existing technologies. Both AFP and 3D printing create severe defects when steering as they buckle the tapes. Steering performance is improved with very narrow tapes, but quality and productivity are much lower. Icomat has developed and patented the world's first process that can fiber steer without any defects at all. This is also achievable using very wide tapes and high deposition rates, enabling very low costs and industrial production. Our core product is the RTS tape laying system, and we offer this alongside the necessary software and support, enabling you to go from a design to a complete part. The benefits of RTS are staggering. In aeronautics, one of our programs with Airbus and BAE used one of our heads placed at the NCC to manufacture a lower wingskin panel. Our part was 65% lighter compared to the one used today. And the same panel produced using steering with an AFP leads to severe defects. We have a similar contract with the European Space Agency where we have shown 15% weight saving on a rocket structure, and this saving alone is worth its weight in gold. In automotive, we recently secured a $2.5 million contract to set up a pilot line to produce demo parts for Jaguar. To minimize costs, we are reinforcing low-cost material, such as SMC, with minimal amount of steered carbon tapes. Also focusing on low cost is a pilot line we are developing with Solvay, where steered 2D blanks can be formed rapidly in complex shapes. The market opportunity is substantial across the 3 sectors, and we currently focus on automotive, where leading OEMs are in our pipeline for high volume production. roughly 40 of our systems would be needed for every 100,000 vehicles. Our team is ready to scale. Our chairman is the ex-CEO of Thales Alenia, and I have spent a decade of my career advancing the field of fiber steering. We have also attracted highly talented technical and business people, and our numbers are growing rapidly. Fiber steering can unlock the potential of composites and drive huge growth for the whole sector. Our vision is to be your partner in delivering this growth. Thank you very much.
There we are. Wonderful. Thank you very much as it went to 0. So perfectly timing. So the timing was perfect, but what else is perfect in terms of what the jury think of what you've just shared? So right now, I believe Brian has a question for you.
Yeah, thank you. Very interesting presentation. When it comes to the layup process, is it capable of high volume production? What type of speeds are you seeing for the layup? And then I'm also interested in the compatibility of the resin that's used in the layup in automotive applications. So like in compression molding, are there compatibilities? What type of resins are you using?
Yes, excellent. So in automotive, definitely it's capable for high volume production. The pilot line we're setting up aims at 100,000 vehicles per year. The main problem is the cost. So as I said, because carbon fiber is expensive, we're using the minimal amount. So to give you an idea, on a 1.5 ton vehicle, we're only placing roughly 20 kilos of UD reinforcement. So it is compatible. So what we're trying to compete is aluminum casting. So to give you an idea, we're estimating is 30% lighter, 30% stiffer, and cost comparable to aluminum casting. And the process is compatible with commercial off-the-shelf prepreg materials. So we're using standard automotive-grade Snap-Cure prepreg.
Just under a minute now for any last questions from our jury members. Anything they're curious about? Okay, we'll take that as you're again satisfied and happy with everything you've heard. Thank you so much, Evangelos. Good luck to you. Good luck to Bristol, and hopefully maybe we'll see you as a winner tomorrow afternoon. Thank you so much. Right, a quick shout out. Excuse me. A quick shout out to those that told us exactly where they are. So, Canada, hello there, welcome. Indianapolis, we have people from Russia, I believe, from Washington, D.C., and we have people from as far as Normandy as well, and even Lille. So well done on winning the championship here in France. Right, we move on. We got, again, if you haven't let us know, let us know. We want to know where you are in the world. Right, we move on to our next finalist, our fourth finalist of 10. This is actually Radisurf, and they are from Denmark. So I believe we're moving right over to Denmark right now, and Mikael Konsfeldt, the CEO, is ready and waiting. Hello.
I am. Hello.
Wonderful. Where are you in Denmark right now?
We are in Aarhus in Denmark.
Wonderful. I have no idea where that is, but I'm sure it is in Denmark. And you're ready with your presentation, and you're ready to share with us exactly why you feel you should be in this top 20. Over to you.
Thank you very much. As mentioned, my name is Mikael Konsfeldt. I'm CEO and co-founder of Radisurf. And first, I want you to look at this picture of a highly advanced and automated assembly line. This is what we could call the 21st century assembly lines. But if you look beyond the robots here, we'll see that we're still using 20th century adhesion technology. And the result is that we're creating unsustainable products in an inefficient way using harmful chemistry. But more importantly, we're designing products that are not fit for the future circular economy. And we are creating a barrier for mass utilization of advanced thermoplastic material and thermoplastic composites. So we want to use the thing away from using pure metals or the current fiber-based materials that are not recyclable, and use much more advanced thermoplastics and thermoplastic composites. And our solution to do that is to enable bonding between these materials using polymer brushes, essentially nanometer polymer chains that are chemically anchored to a surface, forming sort of like a nano Velcro structure on the surface. And we are able to grow these polymer brushes on almost any surface and adapt them to a thermoplastic material. That essentially allows you to weld the thermoplastic material directly to the base material, achieving a strong and tight bonding in an even reversible process. And you can use traditional production technologies like overmolding of your base part or welding of your material and create superior strength. And it's a solution that fits well into some of the major markets, automotive, aerospace, and energy, who needs the unique selling points that our technology brings. And we are working closely with our customers to adapt our technology to their specific needs. And we are ready to deliver the production setup they need and the chemistry they need in a simple process that scales easily globally. We have a unique opportunity to make the world greener using materials that are actually recyclable, something that fits directly into some of the mega trends like lightweighting and sustainable energy with a material that's already recyclable. We are on a step-by-step milestone plan where we launched the first unique product with some of our customers in 2018, and we plan to have the first industrial production plant ready by next year. We have the unique technical team behind this, but also the added business competences, a strong business-oriented board, and a strong technical founder team. And we already received global recognition for our technology through major investments, important soft funding, including strategic investment from the European Commission, and we received awards for our technology every single year since founding the company in 2015. I hope to achieve some more strategic partnerships after this today, and thank you very much for listening.
Mikael, thank you so much for sharing your big idea with us today. So let's move straight over to our jury members, and I believe Karl-Heinz has a question ready and waiting.
Yes, I have one question for you. We are using bonding technologies not only to join dissimilar materials, it's also an important technology to increase stiffness. So can you tell me about your stiffness performance you can achieve your technology in comparison to the standard bonding technologies?
Yeah, so essentially what we create here is a direct bonding between the materials. So if you're creating hybrid materials, essentially from metal and composites, you have a direct bonding and therefore a very stiff bonding between your materials. But our material does not add stiffness on its own, so you need to have that in your structural component.
Thank you.
Still a little bit of time left for...
how do you control a bond line?
Excuse me?
How do you control this bond line?
Between the materials? Essentially, it depends a lot on the specific product. But essentially what we do is we coat, if you take a metal and a thermoplastic, a hybrid material you're creating, we're coating the metal part, and then you need to weld your thermoplastic part on top of that. I believe you also saw a startup earlier this morning doing welding of thermoplastics. Our solution would allow you to use that kind of welding, other kind of welding techniques, and create that strong bond line between the materials.
Mikael, thank you so much. Wonderful to hear your big idea, and hopefully we'll hear your destiny in this competition tomorrow afternoon. Thank you so much.
Thank you.
Right. Again, remember, we're looking for 3. If you've just joined us, this is the Startup Booster competition. We heard this morning 10 big ideas. We're listening to another 10 big ideas right now, innovation within the composite industry. And we are looking for 3 winners, just 3 winners, equal winners that will walk away, winners of this competition. But here's the thing. These are 20 of the best startups out of more than 200 across 30 countries. So you hear something you're curious about, you hear something you like, or maybe something that your network, somebody in your network might like to hear. Join them over at the Startup Booster Village at the Digital Trade Show, and you can connect with them, talk to them, start up a conversation. Even if you're skeptical about some of the ideas, start a conversation, because you never know. A conversation here might actually blossom and become something stronger and even fruitful in the future. Let's move on now to our next startup. We are already on the 5th startup, already hearing these great ideas this afternoon. We move over, once again, another long haul flights from Denmark, Europe. We go across the Atlantic and we're back in the USA, because we've got Steelhead Composites, and I believe Andrew Kors is ready and waiting. Andrew, are you there?
Yes, thank you very much.
Fantastic. Andrew, where are you in the US right now?
We are in sunny Golden, Colorado.
Sunny Golden, Colorado. Listen, here right in Paris, those of you that are in Paris will know right now, it's beautiful, beautiful, beautiful hot weather. So we can feel, we're almost in the same place. Right. Are you ready? Yes, you are. Your presentation's ready. You're ready to share your big idea. 3 minutes. Over to you.
Thank you so much. This has been a very interesting last year. We were supposed to be presenting this time last year, but lots has happened since then. In particular, we've had some very exciting news, especially on one of these megatrends that we have ended up right in the middle of, and that's in hydrogen. So with the new European Green Deal coming online and the massive investments in Europe, as well as in other countries across the globe, hydrogen has gone from an idea that has been 5 or 10 years out until something that is happening right now, with Goldman Sachs calling it a investment opportunity that is in excess of $10 trillion by 2050, and Bank of America calling it the best investment opportunity since the semiconductor. So how does steelhead fit into this, and how do composites fit into this? Storing this massive amount of generated hydrogen is going to be a big challenge. And composite pressure vessels can be a cost-effective bulk storage solution, but with some caveats. We need to make the tanks smarter. One of the benefits of composites is that we can have two materials. We have a liner, we have an outer shell. We can embed telematics. Steelhead has been developing technology for implementing smart tanks. These are tanks that have embedded health monitoring and allow us to control, like in a battery, where we have things like bad cells. The opportunity is to increase the utilization of composite pressure vessels to store the massive amount of hydrogen that we see coming online. Even without this technology, the market is expected to be over $3 billion, growing from $200 million today by 2026. And we can exceed this by having better tanks. We can have tanks that have a reduction of safety factor without reducing safety by embedding these telematics and making them safe tanks. We have taken our technology. We currently design, engineer, manufacture, test, and certify tanks that we sell to a global audience of some of the best companies, the most discerning companies across the planet. We have the traction already, we have the manufacturing capability, and we have the technology and the team to pull it off. With over 70 years of composite pressure vessel manufacturing in our facilities in Colorado, we have the who's who of automation, of composite pressure vessel design and engineering, and a world-class team. And we would love to work with any of you to help expand what we're doing at Steelhead. Thank you.
Wonderful. Thank you so much. Let's hear from our jury straight away about how they felt about what you've just shared. And I believe Brian has a question for you right now, Andrew.
Question, you referenced the safety factor. What is a typical safety factor today? And then with your telematics, what could that be reduced to? What kind of a benefit do you see there?
The current safety factor for on-road is about 2.25 times burst factor over operating pressure, and for stationary or gas transport is 3x. And we believe we can get that down safely to a 1.75, which would reduce the amount of carbon fiber by about a half of what we're using right now, and allow us to cost competitively compete with alternative materials such as stainless steels.
Thank you, Andrew.
Okay, another question perhaps?
Yes, I have a question. If we talk about the technology, so there's a lot going on this space and on hydrogen storage, and my question for you is, what makes your technology unique compared to what exists?
The uniqueness of our technology is that we have it implemented. We have certified hydrogen storage solutions that are in use in aerospace, in marine, and stationary, and transport. And we have demonstrated that we can monitor the health of a vessel through 2 different programs by embedding the sensors between the liner and the carbon fiber. And that puts us in pretty rarefied company.
Wonderful. Andrew, thank you so much. for sharing your big idea, sharing your concept, and good luck with that. And we'll see where that actually goes to in the future. Thank you so much. From sunny Colorado as well. Right. It's time to go on to our next finalist. But remember this, we're already halfway through. So we've already heard 5, a tough decision, definitely a very tough choice for our jury members. But here's the thing. If I asked you right now, the finalists you've heard, if you had to pick a winner right now, who would you pick? Let us know in the chat. Let us know exactly what you think or who you think should walk away a winner if you had to choose, if you were in the driving seat and actually had the authority to choose. You don't, our jury do, but we'd love to hear what you think. We move on now to our next finalist of this session, which is in fact, again, we actually don't go anywhere in the US. We stay in the US because we're going to hear elemental coatings, and I believe Brian Huskinson is there ready and waiting. Brian, are you there?
I am, yeah.
Wonderful. Where are you, Brian? Where in the US are you right now?
We're in Houston, Texas.
Houston, Texas, right. Houston, Texas. We're here in Paris. Everyone else is around the world. You've heard where they are. So it's a global viewing and a global listening of your pitch. So 3 minutes, over to you.
Great. Well, my name is Brian Huskinson. I'm the CEO of Elemental Coatings, and we're a company devoted to solving problems caused by ice and scale. Just to put some numbers around the scope of the issue here, every time a large passenger jet's de-iced, it costs $13,000. Global annual spend on de-icing fluids exceeds $800 million annually, and that's just on the fluids. It's not on the equipment, not on labor, not on whatever cost you would assign to frustrated and delayed passengers. There's over 10 million megawatt hours of lost energy production in the wind energy space as turbines need to be shut down or curtailed to prevent damage due to ice buildup on the blades. This not only costs operators over $1 billion a year, but it puts many millions of tons of extra CO2 into the atmosphere. There are also, just in the U.S. alone, over 20,000 slip and fall injuries annually caused by ice that lead to lost work days. And then these claims each individually cost many tens of thousands of dollars. On the whole, we believe there's a $3+ billion addressable market across various sectors of the economy. So, sorry, my slide thing went away here. How do we solve this problem? Simply put, we make it difficult for ice to stick to surfaces. So we have a passive coating. It looks, feels, and functions like a normal paint. Hopefully you can see a video here start playing on the right-hand side of the screen. This middle step has been treated with our coating, and you'll see how easy it is to remove the ice. This is a polyurethane-based chemistry. It's compatible with existing spray equipment, and we do have the IP licensed exclusively from the University of Houston. I want to show another example of our coating in action. This is a partnership we have on the F-35 Joint Strike Fighter. Again, I'll get a video going here. Top blade is coated with our technology, bottoms uncoated. This is sped up, of course, from real time, but you'll see the difference in the frequency and extent of the ice shedding events in this icing wind tunnel test. Overall, a 4x reduction in the ice buildup. So just a little bit about where we are and where we're headed. I mentioned the F-35 work. We also have some active collaborations with Boeing around the B-52 and some rotorcraft. We have passed rain erosion tests, which I believe we are the only anti-icing coating to have done this. We've also been very successful in raising non-dilutive funding. Next steps, we're currently raising money to expand our offerings and continue our product development. And just one final note about the team. You can see me there on the left. Spent 5 years at McKinsey, did a PhD in applied physics at Harvard, and our CTO, actually co-inventor of the technology, is a faculty member at the University of Houston. So with that, I'll pause and take questions. Thank
Wonderful.
you.
And with that, you've come to right at the end of your time, right on the dot. Right, let's move over to our jury members and hear what they have to say. And I believe Jelle has a question.
Yeah, thank you, Brian. What is the durability of your material? How could you withstand erosion? So if I think, so I'm from Airbus, so if we coat it with your material, how do you withstand the erosion resistance, and what is actually a kind of a disadvantage if you think of aviation industry of your material?
Yeah, so in terms of durability, it's obviously application dependent. The primary testing we've been doing has actually primarily been focused on hitting some of the DoD mil specs. So specifically, there's some MilPref 85285 top coat spec, and so we're well on our way to getting our coating qualified towards that spec. And obviously, as part of that, you have to hit all of the durability requirements for the specification. So, but it really depends on the application and which parts you're looking at. If you're looking at leading edges or horizontal wing surfaces or sensors, so can't provide a universal answer. But I will say that we have passed some of the intercoat adhesion rain erosion tests, and we do expect to be able to hit all of the MilPref specs that are needed for at least DoD applications.
Another 30 seconds on the clock. Any last questions?
Yeah. Did you do any experiments if your coating also would help to save fuel?
So from an aerodynamic standpoint, our coating performs, and we've basically benchmarked it against the existing coating, so we're not trying to outperform from a pure aerodynamic standpoint. Now, if you look at just having less ice buildup, obviously that affects the aerodynamics and therefore the fuel efficiency. I don't have any kind of at scale or good pilot level data to indicate the extent of the savings beyond.
I'm just going to have to stop you there. Only because of time. Only because of time, to be fair and square, okay? But wonderful. Thank you so much. Thank you for sharing, and good luck. And again, maybe, just maybe, we'll see you tomorrow as one of our 3 winners of the Startup Booster Competition 2021. Right, moving on. We move on now to our next finalists of the 10. Already on number 7, we're in America at the moment. Well, we've just been to America, Houston. We get on a plane and we cross the Atlantic and we find ourselves in La France, somewhere where I can just feel the next person is very close, in fact. I might be wrong, but I feel he's close. Marco Cavallari. Marco, are you there? So close, yet so far. Marco, are you there? I can in France. We're in France. Probably he's in Paris. Maybe he's probably next door, perhaps. Okay, what we'll do, a couple more seconds before we move on, perhaps to our next finalist. Okay, what we're going to do, Marco, if Marco joins us a little bit later on, we'll try and squeeze him in towards the end. But what we'll do right now is move on to our next finalist. So jury members, just make a note of this. We're moving on to our next finalist, our 8th finalist. And this is Weave 3D. From the US, Weave 3D, and I believe we have, hopefully, Christopher Oberst on the line. Christopher, are you with us? Maybe Christopher and Marco, maybe they're on a Zoom call together right now, perhaps. Okay. Christoph, are you there? Are you coming through? Okay, what we're going to try and do now, again, we're going to try and get through to Christopher coming through right now from the US, if you're with us. Okay, what I'm going to do right now, again, clearly there's a little bit of a technical problem here that we're dealing with as we speak, as this goes on now. I'm just going to now consult quickly with my team. How are we doing? Will we be able to maybe go to our next finalist? I think we have somebody coming through. I can feel it.
But I cannot hear you. I can see you moving.
Hello.
You're smiling, which is beautiful.
Can you hear me?
Yes.
Wonderful. Marko,
Now I can hear you.
you don't know how it feels for me to really see you right now. I feel I've been waiting an entire day to see you. Marko, you're in France right now. Where are you?
South of Paris, Saclay.
Okay.
Orsay is the name of the city.
Wonderful. That sounds beautiful. Right. We're very close, in fact.
It is.
But our technical issues so far apart. But anyway, I think we're okay now. You have 3 minutes. You know what you have to do, and you know how to do it. Over to you.
Thank you. Hello, everybody. I'm very excited to present our company and our technology for revealing the invisible during the production cycle time. Why is this important? First, many industries, like transportation, use lighter and lighter components to reduce the carbon footprint and to support their electrification. Second, there are big expectations on quality 4.0 for the reduction of the cost of poor quality. On average, these costs account to 5% of the company's revenues, according to the French normalization body AFNOR. This is huge. For these reasons, there is a growing need for quality and process control solutions which can be directly deployed on the production line. They need to be penetrating, contactless, harmless, and rapid. But current solutions do not satisfy all these requirements simultaneously. For example, X-ray computed tomography cannot do inline control because it takes tens of minutes and it is hazardous, which doesn't help. That's why we offer to the market our game-changing non-destructive testing solution based on ultra-fast terahertz pulses. It is fully automated and it uses a patented detector which is 10 million times faster than the state of the art. This is our key technical differentiator, and it allows our technology to be directly deployed on a production line to do dimensional control and defect detection. For example, it can detect voids, delaminations, inclusions, fiber waviness, and other defects in composites. It can control a glue bead or a weld line in assembled parts. It can also characterize a coating, either monolayer or multilayer. We address a broad market estimated to be worth 750 million per year and growing at a rate of 7%. We offer lab services, on-site inspections, and the sale of automated systems available through channels for a worldwide coverage. Our ambition is to be the European leader in our segment by 2023. We are 4 years old and we have traction. We have a distributor for plastic injection molding market, seed fund with Socomore, and also we have done many POCs. We progress rapidly because we leverage on 10 years of academic research and because we leverage on a strong team with 6 people. Collectively, we have 50 years of collective experience in technology and business developments. What I expect from this event is to meet customers and investors for our next funding round. Thank you.
Marko Cavallari, we got you back in the end, and you didn't disappoint. You shared your big idea with us. Right now, we're going over to our jury members once again and hear how they felt about what they've just heard. And I believe Marcus has a question right now.
So I understand it's a service business model that you're offering. It's not is it a software solution? Can you maybe explain again the business model?
Yeah, so we offer systems to do the control, and we also offer the service for the companies which are interested in services as opposed to purchasing a system. And these services are also helpful to set up new processes, for example. But we do offer a full system, which is hardware and software.
Got another 60 seconds on the clock for any last questions, perhaps.
I'll ask questions, Brian. You mentioned coatings, so we're looking at film build measurements, things like that from a terahertz perspective. From a composites perspective, directly, what type of benefits do you see there using the terahertz method?
Faster.
We can analyze stratified materials. We can see the laminations, for example. We can say at which depth it is located. We can characterize it. We can also analyze composites like honeycombs, where other technologies like ultrasounds struggle because they do not propagate in air. So we can address this multitude of applications. We can also follow in-time processes. We can characterize tapes. So when you manufacture a tape, you can control the thickness, density variations, fiber waviness, and the tape deposition, like automated tape deposition. So there are many applications of our technology.
Thank you.
Wonderful. There's a little bit of time now. Last quick question from somebody, perhaps.
Yeah, what is the main differentiation between your solution and the ultrasonic state-of-the-art technology?
Well, we use terahertz, which is electromagnetic waves. They use sound, and our technology allows to go through porous media like foams, whereas ultrasounds cannot do. We have a very good resolution. Our systems are very easy to use, and they're contactless, which is very useful in many applications where you don't want to have a contact medium.
Okay, understood. Yeah, understood.
Marco, wonderful. Excuse me, wonderful. Thank you so much. And let's see if you end up one of the 3 winners of the competition. Thank you so much.
Thanks to you.
Right, we move on swiftly to our next finalist. You heard his name earlier on as we were trying to find him as we had a few technical difficulties. They are sorted now. Everything is good. So hopefully we have Christopher Oberst on the line from Weave 3D in the US. Is that right?
Yes, thank you, Peter.
Wonderful, fantastic. Where are you right now, by the way?
We are in Atlanta, Georgia.
Oh, Atlanta, Georgia. Wonderful. What's the weather like there?
Very hot and humid.
It seems to be hot everywhere, unless those of you that are looking in on this, if you've got really awful weather, let us know. Just let us know if you've got the worst. We want to know who has the worst weather on the planet right now. Right. Christopher, you're ready. I'm sure you know what you have to do. You've got 3 minutes and it's all yours.
Thank you, Peter. So Weave 3D is a manufacturing startup that spun out of Georgia Tech back in 2017 to commercialize an advanced composite manufacturing technology that I invented as part of my PhD. So we're specifically addressing one of the challenges that is, namely, traditional composite forming processes were really developed for aerospace and sporting goods levels of production volumes and performance criteria. So this has left high volume, cost sensitive mass market applications like automotive largely underserved by these traditional processes. And Weave 3D provides a processed cost solution that makes composite manufacturing cost effective and scalable for these types of applications. So we do this through a unique rebar for plastics design approach. Using a proprietary composite forming technology that we developed, we convert commercially available thermoplastic unidirectional tapes into a woven consolidated composite lattice structure that we then sell to a plastic molder. So this would be to be combined with something like thermoforming, compression molding, or injection molding, and the resultant lightweight structural composite part, which contains both a continuous reinforcement from the lattice as well as the molded plastic, enables a solution that is a fraction of the cost of a traditional laminate-based approach. Slides have died for a second here. There we go. So we have a full-scale pilot machine capable of forming lattices up to 1.5 meters wide in a high throughput, continuous roll-to-roll or roll-to-sheet production process. And we can, as part of this process, do on-the-fly variation of lattice density and tape materials to optimize this structure and tune it to really match performance requirements locally within the part. So local variation of density and local variation of tape materials allows us to really reduce the overall part cost, while at the same time this lattice format enables a handleable and co-formable solution for secondary molding with injection molding, compression molding, and allows this whole process to achieve very low cycle times. Compared to other composite forming processes on the market today, we're able to achieve equivalent performance at a much reduced cost relative to stuff like hand layup, resin transfer molding, or thermoplastic automotive fiber placement. And our technology is not just limited to structural reinforcement. We can also add functionality to these composites by integrating transmission materials. So the resultant plastic part can have power transmission, data transmission, or thermal heat sinking capabilities built into the structure. And then looking at our markets, we're specifically focused on automotive exteriors and interiors, body in white closures, interior panels. And we have a fantastic team with a background in operations and sales as well as a broad.
I'm going to have to stop you there, Christopher. I'm sure. I know you're coming to. I know you're on the last slide, just making it completely fair for absolutely everybody, and you were almost there. Right, we move over to our jury members, and let's hear how they felt about what they've just heard. So I believe Karl-Heinz, you've got a question.
Hi, thank you for this nice presentation. My question looks as following. Did you investigate also any recycling concepts for your structure?
Yes, so because we use thermoplastic tapes as our feedstock, the trim scrap that's generated during the tape production can actually be recycled and used as part of that secondary overmolding process. We also have done several projects already where our lattice is being used in combination with either a recycled feedstock, like recycled carbon fiber, or being used in combination with a natural fiber reinforcement. And the combination of those two materials, lattice plus this second material, allows us to significantly enhance the performance of those recycled or natural materials to make them equivalent or better than a virgin material or a virgin engineered material.
Thank you.
We've still got another 30 seconds on the clock. Any last questions, perhaps, for Christopher? No? Okay. Sorry?
Just a real quick question. As far as the handleability of the lattice after it's produced, what does that look like?
So the lattice is semi-rigid in its produced state because of the bonding of all the lattice structures. So even at very low density, it can be lifted. And then once you've heated it for a preforming process, then it becomes drapable again. So if you needed to form a complex shape, heating it and then forming it allows you to do that.
Wonderful, wonderful. Christopher, thank you so much. Thank you so much for sharing your big idea, and we'll find out how big it actually is in the minds of the jury. That's right, in the minds of the jury, in fact, tomorrow when we reveal who those well-deserved winners actually are. So thank you so much, Christopher. Right, we move across now to our next finalist. We were in, where were we? We were in the USA, then we moved to France, then we moved back to the USA. Guess where we're going now? That's right. La France. We're back to France, back to where it's all happening, back to where we are right now. I can feel this person is very close indeed. This is a startup called Yuyo, and I believe Romain Paul is ready and waiting. Romain, are you there?
Yes, I am. Can you see me? Can you hear me?
I can see you, I can hear you, I can almost feel you. Where are you in France?
I'm in the south of France, in Montpellier.
Montpellier.
Only thing, I can't see you. I don't see your screen. Since the cut, I don't see so I'm not saying what's going on with the slides or whatever, but I can do this on my side. I don't know. I'll try to do it if there's no solution, but I don't see you.
Okay. Romain, can you hear me?
I can hear you.
Can you see me?
I don't see you. But we'll do this. Just let me know when it starts, and okay. We'll do this like that.
Okay. Montpellier, beautiful. It must be beautiful there in Montpellier at the moment. Right. What we're doing now, we're trying to fix that for you right now. What can you see on your screen now? Are we there?
No, but I mean, it's okay. We can do this with it.
Oh.
I don't see you, but
I can see your screen now, and I believe everybody else can see your presentation. Can you see your own presentation?
No. But I have it on my own, so I can.
Let's go with that then. We can see it. We can see it. We can hear you. We can see you. We'd love to hear your 3 minutes. Go for it.
Okay, so, just give me a second. It's to pin it. Okay. So I'm happy to present Yuyo. So At UUOS, we're dedicated to rethink completely the way surfboards are built. Why so? Because we've been making surfboards in the traditional way for about 10 years, and we experienced what we call the surfer's paradox, which is the contradiction between our eco-friendly mindsets and the toxicity of the equipment that we use and that we build. So our goal is to try and make the process of making a surfboard and the product in itself more sustainable, so that it can match the way we live. How do we do it? So our recipe is articulated with two main elements: large format 3D printing and biocomposite materials. So we replace the polyurethane or polystyrene foam that usually is inside the surfboards by a hollow structure that we 3D print with recycled PET, and then we laminate this with basalt fiber and bioepoxy resin. So we make performance surfboards that help preserve marine ecosystems. And then our process goes beyond that, because we discovered that thanks to this additive manufacturing process, we can choose where we put the material and where we take it off. So we can go further in terms of search for performance, and as well in terms of ultra customization. And on the whole, we're trying to show that there can be another surfing industry that is not only fun, hedonism, and good-looking girls. You know, that there's something a little bit more thoughtful and sustainable. So we are very happy to see all those new developments in the composite industry, and in combining additive manufacturing with composite industry, because this is what our process is all about. So we've been working for the last 5-6 years in R&D with search labs and to find out a recipe, but we continue improving what we do to try and make every board more performant and more sustainable than the previous one. So thank you for having us here, and we would be happy to meet really the people that we heard during this time and presentations, because there's a lot of things that we are really interested into. So thank you very much, and we are open for questions. I'm sorry, it's been a bit messy at the beginning, but that's okay.
It's all fine. Romain, fantastic in Montpellier, fantastic. You got through it and you shared your idea in the best way you know how, and very bold and informative. Right, we move on now to our jury members, and we let them now ask you the questions they need to ask to dig a little bit deeper about the idea. And I believe Thomas has a question for you right now.
Yeah, so thank you very much, Romain. And so any information about the size of the market?
It's difficult to say, but we have a figure. It's about 400,000 surfboards sold per year in Europe. So this is the market we target. And in this market, there's on the custom parts, that is the one that we address, represent 1/4 of the market roughly. The rest is made in Syria and Southeast Asia.
60 seconds on the clock. 60 seconds. Another question for Romain, maybe.
Yeah, maybe from my side. Do you have any IP protection? Because there's, you probably know, there's competition also from France. People trying to do the same at the same time. So how can you protect your IP, or how do you position yourself in terms of the competition that is also out there?
We're trying to be the first. This is what we've always been doing. We try to pioneer the things. So we have a lot of problems coming in that we discover, but we try to be the first. Now we just received some new machines that with an extruder, so that we're starting to make filaments out of plastic trash that we collect locally. We're moving like this, so we don't have any patent or stuff like this. For us, it's none of our really business. We consider that now the really value added that you bring to a market is being the first to do the things, because otherwise information, you can get it wherever you want. I mean, we cannot ban anyone to 3D print surfboards or to use biocomposite materials. So we just try and source the best bioresin we can, try and find the best fibers, the best processes, and move fast. And this is what we're doing. Fast and transparency. We have nothing to hide. We invite anyone who wants to see what we do and how we do it. So, but we try and move fast and be the first to do the things. So, yeah, it's maybe wrong, but it's been working so far.
Okay, it might be wrong, but it's been working so far. I love that phrase. And we'll see how it's going to work in the future. Maybe working for you tomorrow. Romain in Montpellier, thank you so much, and good luck.
Thank you.
Wow, we are already, guess what, already on number 10. We're on our final finalist of this session, and in fact, number 20 of the whole 2 sessions. So we've already listened to, throughout the day, this morning and now, 19 different big ideas, and right now, we're going to hear number 20. And that number 20 is in a country not too far away from France, a little bit smaller, probably the smallest country of all the countries we've been to today, but will it be the country with the biggest impact? We'll have to find out. So we move over to Luxembourg. So it feels like Eurovision when I say that. Over to Luxembourg, and I believe we have Mark Jacobs on the line with us. Mark, are you there? You are there. I can see you. You're looking great. And now I can hear you. Can you hear me?
Yes, I can hear you perfectly.
Fantastic. Mark, where are you in Luxembourg? I'm probably just in Luxembourg. But the thing is, are you ready? Yes, you are. Your presentation is ready, and we're ready to hear what you have to say. So 3 minutes, over to you.
Fantastic. Thank you. So my name is Mark Jacobs. I'm CEO of Molecular Plasma Group. And I'm here to introduce our molecular grip technology. Because in the end, composites, it's all about bonding the similar materials together. And that is what we enable. So if you think about a couple of major industry challenges, one of them is using highly inert or sensitive materials. Think about polypropylene, PLA, Teflon, ETFE, and so on and so on and so on. Another one is, in order to prepare surfaces of many of these materials, you need a lot of solvents, so you have EHS concerns. And from a process perspective, very often you have a very limited open time. How do we solve all that? We have an atmospheric plasma technology, which is very different from anything you know in the market. And the main difference is that we are able to introduce organic chemistry in the plasma and use the plasma as a vector to bond organic chemistry to any surface. What does that help? What does that do? It results in a permanent modification of the surface. Again, any surface. It's a single-step process. It uses no solvents. And just to give you an idea of the types of chemistries we can use, and this is just an idea, it's a very wide range, and we even go in other industries up to biomolecules. From a layout perspective, so on the left side, you see our plasma spot, which is a spot-like, a torch-like layout. On the right, you see the same concept but linear. So this allows us to scale to whichever width you might want to use depending on your application. So with that, we tick the box. We can do all these difficult and sensitive materials. We tick the box on the health concerns because we actually have 100 times reduction in the use of chemistry. And on the open time, we can achieve 100 times improvement on the open time, allowing completely different manufacturing processes. So tick, tick, tick in each of the boxes. Just a few examples of commercial solutions. So you can put our technology on a robot, integrate it into a manufacturing line. We have standalone systems, so you see a larger width system. And we can even treat powders and particles. So imagine the scope of stuff that you can do with this technology. Our business model is we start with application development services because customers always come with very difficult applications to us. When it's easy, you don't need us. Those, after development, transmit into equipment sales. followed by cartridge consumable contracts and maintenance contracts. And from a financial perspective, you can see that we have traction. We have a highly qualified team. You can at the top you see our team of super smart scientists, and at the bottom it's the business team that brings together a lot of experience. Just a few names. There's a whole bunch of people I can't mention, but you see very familiar names there. Those are quite good references. And in conclusion, we have a disruptive, easily scalable, competitive manufacturing technology that can bring a lot of value to the composites market. So talk to us. See how we can help you.
Mark, wonderful, on time, fantastic, bold, straight to the point and very clear indeed. Let's hear from our jury members about what they've just heard. And I believe, Marcus, you have a question for Mark.
Not yet, maybe later. Maybe somebody else wants to jump in.
Okay, open it up to our jury members. Who would like to ask the first question?
I have one. So when it comes to the scale up of this technology, so if you go big, so what will be your eventual difficulties to scale it up?
None really. So far, we now have, here we have a 40 centimeter pilot line. We have a next pilot line and actually 40 centimeters for industrial in the market. We're now scaling to 1.6 meters, but there's no inherent limitation to go to 2, 3, 4, 5 meters. We can do anything. I'd say that's just engineering.
Okay, thank you.
Got another. We have another 60 seconds on the clock. So any last questions? Yep.
Yeah. So Mark, you mentioned an open time of weeks. It's quite difficult to. I mean, it's wonderful. If you think of a composite, let's say the composite that we're using in the aviation industry, is it that you could have open times of weeks with that technology?
Yes, it is. There's in the end, what we do is we graft a functional group onto the surface that then in the later stage bonds to something. And if you choose, obviously depending on which chemistry you choose, if it can have an open time of up to a year. We had applications on ETFE, for instance, where we demonstrated an open time of up to a year.
Up to that time for a bonding, or I mean, for bonding. Okay.
Yeah.
Okay, that's interesting.
So we functionalized ETFE surface to then bond with a glue system onto something, and that the time between our treatment and the actual bonding operation, 1 year, still fully functional.
Right, that's where we'll wrap up the question and answer session with Molecular Plasma Group from Luxembourg. Mark, thank you so much. Good luck, and maybe, just maybe, we'll see you as a winner tomorrow afternoon. Thank you so much.
Thank you.
Wonderful. Right, ladies and gentlemen, we have now, believe it or not, we've come to the end of this session and the end of the 2 sessions, the Startup Booster Competition 2021. What happens now is very simply our jury members. Very shortly, they will join. They'll be joining Benjamin, part of our JEC team staff here, and he will be running this competition. And together, they will they won't put their heads together literally, but they will sit down and they will evaluate every single startup they've heard, every single big idea, and then this evening at some stage they will know who the lucky 3 well-deserved winners are. Tomorrow at 2:30, everybody else will know, and I'll be sharing at the award ceremony who those 3 lucky winners are. And remember, they walk away with 3,500 euros in a financial prize, together with a fully equipped booth at JEC World 2022 right here in Paris next year. Which again, it's not all about the money, but I would say certainly all about the connections, the exposure, and the conversations that you can certainly have at JEC World 2022. All that leaves me now to say is those of you that joined us, thank you so much. You could be doing, and you know this better than me, around the world, you could be doing so many other things right now, but you decided to share your hour with us. Our jury members as well, a big thank you to our 5 jury members from this morning and now as well, who again gave up their time, gave up their knowledge to help us decide who those lucky winners are as well. So all that leaves me now to say is join me tomorrow at 2:30 for the award ceremony. And remember, just before that, we'll be hearing from an exceptional keynote, a gentleman. Now, if you're from France, you'll know exactly who he is. If not, you would probably have heard of the flying man from Marseille. He will be sharing with us all about his journey, how he can fly, how he flies in a jetpack, and some of the new things he's doing as well. That's all tomorrow. Join me back here, 2:30, and I'm going to join everybody back now, all the pictures, all our startups, all our jury members for one last wave. Thank you so much, and we'll see you tomorrow.